Hey, what's going on? Welcome back. Patrick here from All Things Mathematics, and moving on to the next question, another equation to solve here. So this one is looking complex when you look at it the first time, but once you actually get into solving it, it's actually not too bad. There's going to be lots of logarithmic and exponential rules that we can use to really simplify this equation, but initially when you look at it, it does look complex. We have 4 to the power of, and then all of this is in the exponent for this 4. 5x plus 1 in brackets times this log base 4, and then 4 over 9, and then that's equal to 8 over 27 to the power of 7x plus 2. So the first thing I'm going to do here is I'm actually going to take this entire expression that's in the exponent with this base of 4. So let's maybe write it down here. So I'll have 5x plus 1 log base 4, 4 over 9, like this. And I'm going to try to simplify this first. Now, this 5x plus 1, you can treat this as like a coefficient that's in front of this logarithm, right? You can maybe split these up in brackets. It's like this expression times this expression. Then if you remember your log rules, if you ever have something in front of a logarithm, like a coefficient, this could be a number, this m value, right? So it could be just a constant, but this m value could also be an expression like we have here, right? Just anything in front of the logarithm, because this 5x plus 1 was in brackets. Now, if this 5x plus 1 wasn't in brackets, if it was like 5x plus, maybe 1's not the best example to put, but let's say it was like 5x plus 2 log base 4, 4 over 9, then in this case, only the 2 would be in front of the logarithm, right? Not the 5x plus 2, but because the 5x plus 1 was in brackets, that's the key to see here, that that's the entire coefficient in front of the logarithm. And whenever you have, going back to here to this rule, whenever you have a coefficient in front, you can always take that coefficient and bring it to the exponent, like that, right? So I can take this 5x plus 1 and bring it to the exponent here of the 4 over 9, using the 4 over 9 as a base. So I'll have log base 4, and then let's maybe put square brackets here. It's going to be 4 over 9 to the power of 5x plus 1, like that, right? So all I did was I took this 5x plus 1, brought it to the exponent, like that. And so you may be asking yourself, well, why did you do that? How is that going to simplify things? Well, it's pretty key because we have this base of 4, and now we have this logarithm of 4. And there's another rule, so I'll write it in a different color here, that if you ever have b, let's call it b, some base, to the power of log same base of any expression m, that's just going to equal that expression, right? So if I, for example, have, let's say, 5 log base 5 to the 4, this expression is just going to equal the 4, right? It's going to equal whatever that m value here is. Now, that doesn't necessarily have to be a constant. Again, you could have like an expression. You could have like 4x plus 1, right? If you had something like this, it would equal 4x plus 1. Well, using that over here, let's erase some stuff, create some room here. So I'm going to rewrite this left side as 4 to the power of this, this simplified expression that we had for this exponent when we brought the 5x plus 1 up, right? So we'll have log base 4, 4 over 9 to the power of 5x plus 1. And that's all in brackets like that. Well, notice that, let's bring in another color. So notice that this entire expression is like this m value. right? Same thing here, how we had like 4x plus 1 as an entire expression in brackets. These were the same base. It was just equal to that expression, or it's just equal to m. Well, here we have 4 log base 4. And so using this rule, we know that this entire expression is just going to equal whatever that bracket is there, right? And so what we can do is we can rewrite this left side as 4 over 9 to the power of 5x plus 1. Like that. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. Right, so we took this entire left side over here and we simplified it to just be that. And that already is looking a lot nicer, a lot more simplified. And so here we have an updated equation, right? So on the left side, simplified to 4 over 9 to the power of 5x plus 1. And then keeping this right side the same, we have 8 over 27 to the power of 7x plus 2. Already looking a lot nicer, a lot more simplified, and we just have to solve for this variable x here. So a couple of ways to do it. Because the variables are in the exponents, you could log both sides, so that's one thing you can do, and then you could bring these exponential, or these expressions, sorry, that have an x attached to them down. You can bring the exponents down. However, that's always my last resort. Before doing that, sometimes you do have to do that. But before doing that, I always check, can I take an expression or an equation like this and make both sides have the same base? And notice that in this case we can, right? The 4 over 9, we can rewrite that as like 2 to the power of 2 and 3 to the power of 2. And so that's going to equal 2 over 3. To the power of 2, right? 4 over 9 and 2 over 3 to the power of 2, that's the same thing. And then notice that 8 over 27, we can rewrite that as 2 to the power of 3 over 3 to the power of 3. And that's basically equal to 2 over 3 to the power of 3, right? If you ever had something like this, 2 over 3 to the power of 3, you would take the exponent, distribute it to the numerator and denominator, you'd end up with 8 over 27. And so notice that both of these expressions, both of these fractions, I can rewrite them with the same base of 2 over 3. So that's what I'm going to do. I'm going to go, let's put another bracket here. So 2 over 3 to the power of 2, like that. And that's going to be to the power of 5x plus 1 equals the 8 over 27, that's 2 over 3 to the power of 3, right, that we just did here. And that's going to be to the power of 7x plus 2. And now notice that we have both sides with the same base. And at this point, we could actually drop the bases. Actually, before doing that, let me show you. Let's get rid of a bunch of brackets here. You have to be careful here with this 2. Okay, these two exponents are multiplying, right? Whenever you have like b to the m to the power of n, that's equal to b to the power of mn, right? Those two exponents are just multiplying. However, this 2, it's multiplying by this entire expression, right? It's not just multiplying by this 5x here, right? So you got to make sure you put that in brackets here. This 2 and this 5x plus 1, you're going to multiply the 2 by that entire expression. Same thing here, the 3, you're going to multiply it by that entire 7x plus 2. So I could rewrite this as 2 over 3 exponent 2 bracket 5x plus 1. And then over here, I can rewrite it as 2 over 3 exponent 3 bracket 7x plus 2. Like that, right? This step is not necessary. You could have just dropped the bases right away. but just to clearly show you what that exponent, what that expression in the exponent is going to be. And then from here, you could just drop the bases of 2 over 3. Both of these exponents, 2 bracket 5x plus 1, is equal to 3 bracket 7x plus 2. Both of those exponents have to equal. And so from here, you just have to solve for the x. So what I'm going to do, distribute the 2 inside the bracket, same thing with the 3. Bring all the x values to one side. We'll have 2 minus 6, all the numbers to the left side, all the x values to the right side, just to keep the coefficient in front of the x positive. So then x is going to be negative 4 over 11, like that. And that would end up being the final answer for this equation that we had, right? So again, initially looked pretty bad, but once you start applying logarithmic rules, exponential rules, it does simplify pretty nicely. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.